Hello, am I audible now?
Yes.
Yes.
Yes, ma'am.
Yes, audible.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So let's start with some basic
Ma'am,
theory
yesterday we
from
didn't
week
do SSC.
3 and week. Sorry, what?
Yesterday you said that SSC, that is, some square errors will be a part of week 3. So you kept it for today.
Yes, ma'am. I have a doubt in SSC, ma'am. Some squared error.
I kept it for today, but yeah, we'll discuss it today also. Because
Ma'am, your voice is cracking.
it's a
The
part
voice
of week
is cracking,
3,
Ma'am, your
Ma'am,
voice is
ma'am, your voice
cracking.
is
actually it's a part of week 2,
Ma'am, your
3
voice is
content, and at
dying.
the end we'll cover SSC question. Sorry.
ma'am, your
Ma'am, your
voice is
voice is
Now
cracking.
I'll mute everyone, so you can message in chat only. If you have any particular query, you can raise your hand. After that, I'll unmute you. Now my voice is clear or still cracking? Not clear? Okay. I think there is some internet issue. Session haven't started yet. Let me fix. Hello, am I audible?
Yes, ma'am.
Yes, ma'am.
Hello.
Yes, ma'am, you're audible.
So yeah. Now my voice is clear, right?
yeah, you're audible.
Yes, ma'am.
Ma'am? Excuse me, ma'am.
Yes.
Yes. Ma'am, may I know the timings about the qualifier exam? May I know the timings? You will get a hall tickets now. After that only you can know your timing of exam. When hall tickets will be published before 2 days of exam, I
The
think.
voice is not proper, ma'am.
Written that
I mean,
Still not
till
proper?
January.
it will be released, but till now I didn't get the hall ticket.
Sometimes it's clear, sometimes it's
No one got the hall ticket yet.
maybe tomorrow.
No one got the hall ticket yet. Hmm.
Ma'am, can you first explain the concept of week 3 and week 4 and then do the question?
And mainly week 4,
Yeah.
those
Okay,
polynomial
ma'am.
Can
equations
you, madam, please
and
unmute
graphs.
so we can start?
Madam, first wrap up the theory.
Yeah.
And please mute and start.
First we'll wrap up the theory, and after that.
Ma'am, could you please start with SSC, ma'am? It's
Yes, ma'am.
Okay, you want to start with SSC?
Please,
yes,
ma'am.
ma'am.
Okay,
Yes,
fine.
ma'am.
So we'll start with SSC only. So I'll mute everyone. If there is any particular query, you can raise yours.
Yes, ma'am.
Abhinav, you want
Definitely.
to say something? Or
No,
when-
ma'am. I was talking about SSC, ma'am. Like,
हाँ.
Yes,
Okay.
ma'am. It would be better
And
if it.
Vindhya, if not, you can go.
Yeah, I'll mute, ma'am.
Ma'am, I had a doubt in finding the zeros of cubic polynomials and to the raised to the power of 4 and 5.
Okay. So we'll come to that.
Okay, thank you.
So let's start. So let's talk about SC. So SSE is what? So SSE is actually a method to finding out the error between your data and an expression or a function which will represent your data. Okay, so what happen if you perform some experiment and you will find out some data. So let's say your independent value is x, and based on this x, you will perform some experiment and you will get some output y. So these are your inputs and these are your outputs, right? So you have some certain points or certain data values where you will perform your experiment. For example, if you want to find out how does the room temperature change when you speed the fan or when you uh, use something, right? Or you can say that how does the speed of a car will change if we go along some particular paths, right? So I mean, in particular, we will perform so many experiments, and based on that experiment, we will get some data points. So what does SSE do? So suppose you will perform some experiment and you will get some data points, x1, x2, x3, and x4. In this case, let's say I have 4 inputs and 4 outputs, y1, y2, y3, y4, right? So now what happened in a real world, we cannot do the experiment forever, right? For example, if I say that I'll perform an experiment on some machine, right? And at time t in seconds, let's say at time t in second, at 10 seconds, the temperature of my rod or temperature of my device will be 30 degree, right? At time 20, the temperature of my device is nothing but a replace of 30 degree. Let's say it's 15 degrees Celsius. And at time 20, let's say the heat or the temperature of my rod or particular device is nothing but 25 degrees. So similarly, I'll perform the experiment for 10, 20, 30, 40 times, I mean 40 seconds. And I'll get temperatures, let's say 15, 25, 35, and 45, right? Now I have finite number of data points, right? Finite number of data points. Now what I can do, I can assume some expression that based on these data points, I can assume some expression or I can get some expression which nearly will give me the data points of my what you can say of my experiment. For example, for this particular data point, let me assume this expression: the y is equals to x plus 3, right? So if I say that this expression, this y is equals to x plus 3 will demonstrate my data points, then using SSC, you can check that this expression is valid or how this expression will make when I'll put my data points. So that's the main, what we can say, main concept of SSC, right? Sum square error type. Okay, so what need such kind of error? So actually, what happens? We can do experiment for finite number of data points. If I can find the what we can say precise expression which will give our data points, then it's easy to get our output at any input. Am I audible clearly? Hello? Huh. So SSCs actually say that, okay, if you do some experiment, if you assume some expression regarding your data point, then SSC will tell how much error this expression will make when you put your input and get your output based on this expression. Because I can do this experiment up to some finite time, right? If I want the output when t is equals to 1000, I mean, yeah, 10,000 or 1,000, then you cannot repeatedly do your experiment, right? I mean, it's very tough to get, but I mean, yeah, actually, it's very tough to do experiment up to 10k seconds. Maybe 10k seconds is easy, but you can assume that 100k seconds and for that long time, right? So if we can get an expression for my data point, then it's easy to evaluate the output on any input point. So that's why we always want to find out an expression which will justify our data points, right? So SSC will tell you that if you have given some data point, what does SSC do? SSC will tell that if you have given some data and if you have some expression related to that data, that y is equals to mx plus c in our case, the equation of line, then how much error this expression will make when we try to evaluate our data points, right? So that's what SSC do. So the basic formula of SSC is, suppose these are the data points that y1, y2, and so on, yn, right? And based on your values here, your input values x1, x2, and so on, xn, you can evaluate the values m, xi plus c for all I ranging from 1 to n, right? So what does SSC say? SSC say that your error is nothing but, for error we have to come up with some difference, right? So that's why what we will do, we will take yi minus this data point minus the value evaluated from from our given expression, right? So that means yi minus mxi plus c, and then we will square it. We don't want our error to be negative, so that's why we will square it, and we will add all those terms from ranging 1 to n. That means how many data points we have, we will range that. Okay. So this is a basic formula for SSC. How you will find out your SSC. So whenever someone asks some SSC question, there will be one data set, and you will get some expression. There will be one expression related to that. Now there are two kind of questions anyone could make. First thing is simply calculate your SSC, right? And second thing, they will say that in expression there will be some constant, that y is equals to 2x plus c, right? So c is constant, and they will say that they will give you some choice for c, that c is equals to 2, c is equals to 3, c is equals to, and so on. And they say at what value of c you will find the best fit. What do we mean by best fit? So best fit is that expression which will give you minimum error. Minimum error means the value of SSC. The value of SSC will be minimum when you consider that expression. When you consider that value of C. Right. So this is the main framework of SSC. SSC is nothing but just a method to find out the error between our expression and the exact data values. That if we have some data point, and if we assume that this expression will justify my data point, then how much error this expression could make. So that's one way to calculate this error is SSC. Now, if there is one question where they have given some expression, they have given some data point, but there is one constant, and then they say that find the value of that constant for which this expression is a best fit of your SSC, right? So we can do some example also. We have some example, I think. Yeah, there's a question in graded assignment Victor related to. Okay, so let's try to solve this question of SSC, right? So what will be the value of K so that the SSC will be minimum, right? So what you will do, you will find out the SSC first and then try to minimize your value. So I'll give you 5 minutes to do this question by yourself and then we'll discuss it, okay? Yeah, this is last question on SSC. This will clear your all doubts, I think. So that's why let's try it out. We can go up. I mean, we will cover everything going forward. Yes, Abhinav, you want to say something?
Like how to solve this, ma'am? Like you said, like K constant will be given for the exam, like for you told, but we have to find the constant. So it does not fit in the equation, ma'am. Like will we take K as K or like how to do it, ma'am? Could you please show it?
See, in this case, we haven't given any values for K. So let's just take K to be K itself and then find out SSC. When you will get the expression of SSC, there you can guess that what value of K will give us the minimum error. Let's find out the expression for SSC. Okay, so let's do this question.
Okay, ma'am. Yes, ma'am. It would be helpful, ma'am.
So let's solve this question. So what's given here? F of x is given to be x minus 2, x minus 4, x minus 6, and plus k, right? So at x is equals to 1, x is equals to 1, what will be the value of f of 1? So f of 1 is nothing but I have to put 1 here, right? So 1 minus 2 will give us minus 1, and here we will get minus of 3, and here will get minus of 5, right? So the f of 1 is nothing but minus of 50, right? Similarly, at x is equals to 3, if I substitute here, what I will get? F of 3 is nothing but 3 minus 2 will be 1, multiplied by 3 minus 4 will be minus 1, and 3 minus 6 will be minus 3, right? So that means f of 3 is nothing but 4, plus 3, right? And at x is equals to 5, if I want to evaluate, then f of 5 is equals to 5 minus 2 will be 3 into 1 into minus 1 is equals to minus 3, right? And at x is equals to 6, if I have to evaluate, this is k, right? And at x is equals to 6, if I have to evaluate, then it's f of 6 is nothing but 6 minus 2 is 4, 6 minus 4, 2, 6 minus 6, 0. And again, we have plus k in every term, okay? This is plus k. F of 1 is minus 15 plus k, f of 3 is 3 plus k, f of 5 is minus 3 plus k, and f of 6 is, this will be 8 plus k, right? No, it wasn't removed. I will put it in. So at the end, what I'll get this is not, this is minus 15 plus k, 3 plus k, minus 3 plus k, and 8 plus k, right? Okay, just made a table here. And this is your f of x. Fine. So then if you calculate the SSC is what? So SSC will be that minus 10 plus we have to subtract here our f of 1, right? So f of 1 is minus 15 plus k. So that means minus 10 minus 15. So this will be plus 15 minus k. And then square it. And then we have to add again all the terms, which is 8. No, k is there in everything. See, f of 1 is equals to, what's that? This will be minus 1 minus 3 minus 5 plus k, right? So this is nothing but minus 15 plus k. And similarly, you can calculate f of 3. So f of 3 will be 1 and this will be minus 1 plus 3 plus k. And f of 5 is nothing but 3 into 1 into minus 1 plus k, which is minus 3 plus k. And f of 6 is 6 minus 4 into 2 into 0 plus k. So that means this is only k. Yeah, that's the. Because if you put 6 there, the 6 will get multiplied. I mean, everything will get multiplied by 0. So that's why f of 6 is just okay. Now, if we have to calculate the SSC, we'll just use the formula. So the formula says that minus 10 and minus of f of 1. So minus of f of 1, if we'll do, we'll get plus 15 minus of k square, right? And then we have to add 8 minus of f of 3, right? So f of 3 is what? So minus 3 minus k. And then we have to add again 5 minus f of, sorry, 2 minus f of 5, and f of 5 is minus 3 plus k. So that means plus 3 minus k. And then square it. And then again, we have to go with 5 minus f of 6, and f of 6 is k, right? Now, this is a quadratic equation, right? So at the end, what you will get some equation of parabola type. I mean, at the end of this question, what you will get some expression of this type, that a of k square plus b of k plus c type of thing. And you know, this is a parabola. And you know, the if if the value, if the coordinate of a is negative, then this will be a downward parabola, and the minimum value of this expression, or the minimum value of, or you can find out the root of parabola, which will satisfy this equation. Because the SSC could be the minimum thing, right? So that means what I want to say here, that at the end, when you solve the question, when you solve the expression of SSC, you will get something like that: AK square plus BK plus, right? This is your SS. Now you want SSC to be minimum. That means you want minimum value of this parabola, AK square plus BK plus C, right? And you know how to find out the minimum value of parabola, right? So if this will happen, that this will denote it, this expression will come up with an upward parabola. And you know that at the vertex, you will find the minimum value of parabola. Okay. So that's how you have to proceed. That at the end, you will find out some expression related to k. Either it could be a linear one or could be a quadratic one. So in quadratic, you know how to find out the minimum value of quadratic expression, because if that quadratic expression denotes the parabola facing upward, then the minimum value of quadratic equation will lie at the vertex. Okay. So we will come to all the doubts using graded assignment at the end. Because first I have to deal with every theory. Okay. So is there any doubt in this question now? if we solve it, it will take again 10 minutes. So that's why I'm not solving. Now I'll give you idea that at the end you will come up with a quadratic equation and you know how to find out the minimum value of quadratic equation. Okay. You did not see what this is a very straightforward question, right? Here you have to find out the value of k for which the value of SSC will be minimum. So you'll find out the expression for SSC and that expression will be in quadratic form, in the quadratic form, right? And whenever you have a quadratic form, we associated that to the parabola because this will come in the week 3 content, right? We just have to solve. We have to find out the value of k for which this expression will get the minimum value. Fine. Yeah, vertex. Vertex is the only possibility where we can get the minimum value of parabola. Fine. So Kunal, you have any doubt?
Yes, ma'am. Am I audible?
Yeah.
Ma'am, I actually want to know how much value of SSC can be negligible.
How much value of SSC could be negligible? Actually,
Yeah.
depend. In some cases, the minimum value of SSC will be obviously it will be a positive. Negligible, it depends on your choice. Can come very small.
It cannot be a fixed value, means.
Yeah, it cannot be a fixed value. It will depend on expression. If you change the expression, the value of SSC will change.
But ma'am, if I remember properly, Arpit sir says that we can negligible it to 5.
So actually, I don't know because error is error. So it's depend on your choice how much, how less error you want. So maybe he saved with respect to some question or some particular. I don't know. Okay. So Pushkar, you want to say something? I'll unmute you.
Ma'am, actually, I am having doubt in graded assignment. Could you please allow me to that?
Yeah, see, we'll come at to graded assignment doubt at the end. Otherwise, we will like. I'll come at 2 at the end.
Remember at the end we were not able to ask the doubt, and I am just confused at that question because I had solved it multiple times. The graded assignment question was there.
Yeah, I will come up to your question after the theory part. Okay, that will be fine.
Okay, ma'am. Thank you.
Shivali, you want to say something? Now you can unmute.
Yes, ma'am. Actually, after finding f of 6, what have you done? Can you repeat that step?
We just apply the formula for SSC, the SSC formula, right? That simply yi summation over i's ranging from 1 to n, yi f of yi minus of f of yi whole square, that formula, that square formula.
Okay.
You know the formula for SSC, right? It
Yeah.
says that sum 1 to n yi minus f of xi whole square, right? So this formula. Okay, so I'll jump to the theory part now. Puneet, you can unmute yourself now.
I just wanted to know the answer of that so that I can check with the answer which I have got.
I don't have answer, I think, in this PDF. But it seems you are getting 5 or something, maybe.
I got 6.2.
6.2.
Yes.
Okay. So, I think the answer is between 5 or 6, maybe. Find the value of 16k, they say, na? Okay, so just multiply 6.2. That's 16. No, it won't be 5. I don't know the answer, but you can try it out. So many people are saying 5. 80, they also say 80.
Okay, thank you.
Sujit?
Yes, madam. That least square motivation and SSC are same or different?
Least square. Yeah, they are same. See, in least square also we want to find out the least value. Yeah, I think. Okay, so there are so many hands. Okay, let's go to theory part, otherwise we'll discuss. No, we won't solve another question of SSC now. We can solve at the end of the session or later. Okay. So now I'll move toward the theory of week 3, right? So week 3 is in week 3 we'll mainly consider the equation of parabola. How does parabola look? What are the what are the excess of symmetries? How to find out the slope of a quadratic equation? How to find the roots of a quadratic equation and all those things. Okay. So let's start with the basic definition of quadratic function. So any quadratic function will be of this form. F of x is equals to ax square plus bx plus c, where a is not equals to 0. We want a is not equals to 0 because we want a quadratic term there so that it makes sense to be a quadratic function, right? Quadratic means whose power is 2, right? Okay. So the curve represented by a quadratic function is always a parabola. It will be an upward parabola or downward parabola. And this upward and downward parabola depends on the downward parabola or upward parabola. And both things depends on the sign of your leading term a. So if a is negative, then it will be a downward parabola. And if a is positive, then it will be an upward parabola. And we know that a can't be 0 if it is a quadratic equation. Okay. So this is a thing. And excess of symmetry. So what does excess of symmetry mean? Excess of symmetry and vertex of a parabola. So whenever you have a parabola, then there's some point of parabola, and if you draw a line at that point, then you will find out that both of the wings of parabola will be symmetric about that line. That line is said to be axis of symmetry, and this point is said to be the vertex of parabola. For any parabola given by this expression ax square plus bx plus c, the x coordinate of vertex is given by minus b by 2, right? And that's why this line, since this line will be a line parallel to y axis, right? So that's why the expression of axis of symmetry is nothing but x is equals to minus b by 2, right? So if you have a parabola defined by ax square plus bx plus c, then the x coordinate of vertex is given by minus b by 2a, and the axis of symmetry is given by x is equals to minus b by 2. Why x is equals to? Since axis of symmetry is an equation of y. So that's okay. So these are the two concepts. These are very important if you have parabola, axis of symmetry and vertex. Axis of symmetry is basically that vertical line at about which the parabola will have a symmetric behavior, right? For example, if you have this parabola, then somewhere here is your axis of symmetry. And if your parabola is ax square plus bx plus c, then the equation of axis of symmetry is x is equals to minus b by 2. And the x coordinate of vertex or the coordinates of vertex is minus b by 2a. And you can substitute the value of x is equals to minus b by 2a in expression and find out the y coordinate also, right? Okay. Vertex is what? So vertex is basically a point where axis of symmetry and parabola intersect each other. That's the point of vertex. Here they have written, right? So the point at which the axis of symmetry intersect the parabola is called the vertex, right? And the x coordinate of a vertex of parabola is minus b by 2a, and the y coordinate of a vertex of parabola is f of minus b by 2a, where this is your expression, f of x. Okay. Right. Now we already discussed upward and downward parabola. So upward parabola will happen when a is strictly greater than 0. That means your leading term is strictly greater than 0. Then we have an upward parabola. And in upward parabola case, we have a minimum value. and the minimum value of that parabola will occur at the vertex. So that means minimum value is nothing but f of minus b by 2a, since this is the x coordinate of vertex. So if you have an upward parabola, that means if a is strictly greater than 0, then we have minimum value, and the minimum value will be occur at minimum value at the vertex, and it's equal to f of minus b by 2. So that means if we have an upward parabola, then we have a minimum value at the vertex, and the minimum value is nothing but f of minus b by 2. Okay. What question do you want to ask, Sakshi? Yes, Sakshi, unmute yourself.
Ma'am, actually, I have a question in mock test. I have sent you the images in VChat. That is, the question was, just a second. Ma'am, the question was, a well-educated carpenter is asked to carve out a wooden block in the shape of parabola, that is px equals to x minus 2 into x minus 4 plus k. K is an integer constant. She has been asked to carve it in such a way that the curve px can be best fitted according to the data given in the below table. Ma'am, actually,
Yeah,
I've
right.
sent the image. Do I have to send it again?
You have sent in the chat box?
Yes, ma'am.
Yeah, see, what we can do, we will go through the theory first, and after that we will come up, after that we will discuss the all doubts about mock test and graded assignment. That will be fine for you?
Okay, ma'am.
Yeah.
Thank you, ma'am.
So whenever we have an upward parabola, we have a situation where we can get a minimum value for our expression, and that minimum value will occur at the vertex. Okay. So that means if we have an upward parabola, if we have a strictly greater than 0, then the minimum value is equal to f of minus b by 2. Why f of minus b by 2? Because this is the x coordinate of it, and the minimum value will occur at the vertex. And similarly, if we have a downward parabola, then we have a situation where we can get a maximum value. And the similar thing, that maximum value will occur at the vertex. So that means if a is less than 0, then we have a downward parabola, and we have maximum value for parabola, max value for parabola, and it's equal to f of minus b by 2. In both cases, we have minimum value and maximum value at f of minus b by 2, because that's the x coordinate of vertex. Okay. Fine. Now let's go toward the slope of function. So in case of quadratic function, there's a perfect expression for finding out the slope of function. Slope of parabola, slope of f. Okay. So if you have a quadratic function that f of x is equals to ax square plus bx plus c, then the slope is actually given the slope at a point at point x. The slope at point x is equals to 2ax plus b. And the reason behind this slope you can find out using either by this thing that you'll take 2 points and then draw a line and then try to solve it. But that's not a good way to do it. You will find out the reason for this slope in week 5, where we discuss the derivative concept. Okay. So for now, you can just remember this thing that if you have a quadratic equation, then slope at a point x comma f of x is nothing but 2ax plus b. Okay. Now we have quadratic equation standard form. Yeah, so the standard form of quadratic equation is ax squared plus bx plus c. And the roots of equation. So what do we mean by roots of equation? Roots. So roots are nothing but those values of x for which f of x is equals to 0, right? So those values of x are known to be roots of x. And in quadratic equation, we have a very nice formula to find out the roots. Since we have a quadratic equation, so ax squared plus bx plus c, right? So whenever we have a quadratic equation, it is possible to have at max 2 roots, right? And the equation of roots is nothing but, the formula for finding out the roots is nothing but x is equals to minus b plus minus under the root of b square minus 4ac by 2. Right. And this formula is, you have already seen. This is known as a Sridharacharya formula. And this formula is very useful to find out the roots of any quadratic equation. You can put the values of a, b, c according to your quadratic equation, and you will find out the roots. So this is a one way to find the roots. Okay. Now using this expression, we can find out some condition on our quadratic equation that when we have real roots, when we can have same roots, and when we can have only no roots. Right. So in this formula, there is a one square root term is there, right? So under the root of b square minus 4. And you know that whenever b square minus 4ac is less than 0, negative thing. So for negative thing, we don't have justification for our square root now, right? So that means whenever b square minus 4ac, we cannot find our x. So whenever we have b square minus 4ac is less than 0 for our quadratic equation, there is no roots for those equations, right? No real roots, right? And if this thing will come out to be a perfect square, or not perfect square. So let's say that your b square minus 4ac is equals to 0. Then you will get x is equals to minus b by 2. So that means here you will get one root, one real. So when you have b square minus 4ac is equals to 0, you will get one root. When you have b square minus 4ac strictly less than 0, you won't get any real root. In the case of strictly greater than 0, you will get two root because plus and minus sign is there. So you can easily find out the two real roots. Okay. Now observe, using this formula, you also can check when you will get a rational root, irrational root, and all those kind of things, right? B square minus 4ac by 2. So now suppose your b square minus 4ac is strictly greater than 0, but you are under the root of, b square minus 4ac is not a perfect square, not a perfect square. Then what will happen? You are under the root of b square minus 4ac will be an irrational number, right? This is a notation for denoting the set of irrational number. So when you are whenever your b square minus 4ac is not a perfect square, then you will have irrational roots also, right? Because obviously this is not a perfect square, and you have to add and subtract, add and divide by something. And obviously is any real number. In this case, you can have irrational roots, right? But if you're under the root of b square minus 4ac will be a perfect square, then you will have a rational root. The nature of root, either it's irrational, rational, real, or anything, you can judge by this term under the root of b square minus 4. Just put your condition here and observe what are the values of x could be, right? Okay. So this is a basic three basic conditions for having roots greater than 0, equals to 0, and less than 0. And the reason behind that is simply this formula. X is equals to minus b plus minus under the root of b square minus 4ac by 2. Okay. Yeah, they won't ask about complex roots because we haven't discussed anything about complex number. Okay, so now step to solve quadratic equation by factorial. Okay, see, now there is this method you may learn in your schools also, that whenever you have quadratic equation, if there is a certain situation that the middle term b can be parted into two terms, alpha and beta, in such a way that alpha plus beta is equals to this term b, and the product is the term C, then you can easily factor out your expression in this one, right? So that's a basic high school thing, that if we have some this type of thing, that ax square plus bx plus c is equals to 0, and you can find out alpha and beta in such a way that alpha plus beta is equals to b, and alpha into beta is nothing but AC. Why I'm taking AC? Because you have to take the product of these two terms. Here the coefficient is 1, that's why they only taken 2, but you have to take AC there. So if you find out such an alpha and beta, then you can easily factorize your equation in this one, that x plus alpha, x plus beta is equals to 0. And from there you can find out your roots. Okay. Please mute yourself. Okay. Now there's one more method for finding out the roots of quadratic equation, which is known as a completeness of square method, right? Completing the square. So in completing the square method, what you will do, you have ax square plus bx plus c is equals to 0. Here you will add some d, and also d in the right hand side and left hand side as well, and try to make this expression to be a perfect square of this form, that either some a bar x plus d bar square is equals to d type. This perfect square method only works when you have to add, when you will add something and that will become a perfect square. If you have to subtract something and that will become a perfect square, then this method won't work that much. That's why we have to add something and make it perfect square, not subtract. Because if you subtract, then there will be minus d here, and you have to take the under the root of, square root of minus quantity, which will lead us to some difficulties, right? So that's why the completing square method works only when you have to add something and make our expression to be a perfect square. Okay. About this thing. Okay, fine. Now we have some examples here. But I'm skipping those examples because you have already done. Yeah, this is an example for finding, is an example for what we can say, that this completing square method. Here, observe that what they do, they will add up this quantity 6 by 2 square in both of the terms, right? 6 by 2 square, 6 by 2 square. And here we'll get some expression which is of the perfect square, x minus 3 square. And here we'll get a positive quantity. If you get a negative here in the right hand side, you cannot find the root. So that's why for applying this perfect square method, you have to get some positive thing in your right hand side. Right hand side should be positive, and here you have some square type of thing. This situation should happen if you have to apply a completing square method. Okay. So this is one easy example. Yeah, I'll share the PPT in the chat box only. Okay, so now let's move towards the polynomials. So first, the definition of polynomial. So polynomial is an algebraic expression in the terms of a constant and the powers of x. So what is the polynomial? So polynomial is this, that f of x is equals to a n x to the power n plus and so on a naught x to the power n. Here a n is not equals to 0. We'll take this since we want leading coefficient not equals to 0. Otherwise, we cannot. It's meaningless if we will just add 0 into x to the power 5 type of thing. So we want our leading coefficient not equals to 0. So such a type of expression is known as parabola. And here the powers of x, that all powers of x belongs to the natural. That means we don't want power of x to be -1, -2 type of thing. All the power of x will be natural numbers only. Okay. So this is a basic definition of parabola. So a parabola is an algebraic expression in which The only arithmetic is addition and subtraction, multiplication, and the powers of exponents are natural. Okay. And the domain of polynomials are always a real number, and the range is all not the range. The codomain is again the real number. Okay. The domain of fx is the real number, and the range depends on the function f of x. But the codomain is the real. Okay. Now here we have certain examples of parabola. So types of parabola. So first is in one variable. If you have only one independent variable means x or y. If we change our x and y, the expression will change. So that's x is called the independent variable. Right? So when we have only one variable, that means x. So this is a one type of parabola. When we have two variables, then this is a one type of parabola. And then when we have three variables. Yeah, sorry. Polynomial. Thank you. Sorry. Now we'll classify our polynomials using the degree of polynomial, right? So when we have only constant terms there, so that means the power of x is 0. So those polynomials are said to be constant polynomials. So sorry, I have to parable. And when the degree of when the power of x is 1, we'll set that it's a linear polynomial, x to the power 1. When the leading power of polynomial is 1, then it's said to be a linear polynomial. When the power of leading term is 2, then that polynomial is said to be a quadratic polynomial. And when the power of x is 3, then that is said to be a cubic polynomial. And similarly, we'll name a quadratic, biquadratic, and all type of polynomials. So these polynomials we named based on the power of x, the leading coefficient, leading terms power, right? This is the leading term power, x to the power n, x square, 2x cube, 2x to the power, right? So using these leading terms power, we'll define constant linear polynomial, quadratic, cubic, and biquadratic type of polynomial. Okay. Here, okay. Yeah, the power of exponent. Now, there is another justification of polynomials, which is known to be monomial or binomial or trinomial. It's actually depend on the number of terms. How many number of terms are there in your polynomial? So if there is only one term in your polynomial, then that polynomial is said to be a monomial. If there are, for example, here we have x to the power 10 is a monomial, 6x to the power 9 is a monomial, e is a monomial, 5 plus 4, since this is only 9, so that's why it's a monomial. Monomial means how many distinct terms are there, then that polynomial is said to be a monomial. Similarly, binomial means if there are two distinct terms, right? So for example, this x to the power 10 plus 10. Here we have two distinct type of term. One is x to the power 10 and another one is 10. That means one is constant and another one is exponent, right? So such type of polynomial is said to be binomial. And similarly, if we have three distinct terms, I mean three distinct powers of x, for example, x to the power 10 plus x square plus 1, right? So this is a polynomial where we have three distinct exponent powers, right? So such type of polynomial is come under the category of trinomial. Okay. So these are the classification of polynomials. First is based on the degree. Degree means x to the power, the higher exponent power is said to be a degree of polynomial. So constant, linear, quadratic, cubic. Another one is how many distinct terms are there. So monomial, binomial, trinomial. Okay. So for example, if I say this polynomial, that x to the power 10 plus 2x to the power 10 plus 5x to the power 10, then is this a trinomial, binomial, or monomial? In which category you will consider this polynomial? Monomial, binomial, or trinomial? Why trinomial? Monomial, right? Because all have the same powers. So you can add all those things and write it to be 7x to the power, 8x to the power 10. Right? So that's why it's a monomial. So here you have to pay attention that the powers of each term should be distinct. Then only you will count how many terms are there. Okay. Now we have operations on polynomial functions. So basic addition and subtraction. Addition will be done using, same power terms will got added together. Distinct power terms won't be added together. So it's straightforward addition and subtraction. And multiplication is also term by term multiplication. For example, if you have to multiply this x square plus 1 with x cube plus 2x plus 1, then what you'll do, you will multiply x square with this bracket x cube plus 2x plus 1, and then plus with x cube plus 2x plus 1. Multiplication will be done by term multiplication. You will take one term, multiply by that bracket, another term multiplied with that bracket, and use the operation whatever in between. Okay. So this is a basic multiplication operation of polynomials. Quadratic equations are polynomial of degree 2, basically. Okay, now we'll come with the division of polynomial. So division of polynomial, you may learn in your 12th. What we'll do, that if you have a polynomial px and you have polynomial qx, so we'll just go term by term and try to divide this polynomial. If we have to divide this polynomial, the division only happen when the degree of qx is greater than. That means the degree of qx is greater than or equal to degree of qx. Then only we can divide that polynomial. Okay. Okay, fine. So let's solve one example. This is an example. So in here we have to divide a polynomial by this polynomial. So here observe that we have x to the power in our quotient. So what we will do, we know that if we multiply it by x cube in this term, I'll get x to the power 5. That's why I'll do first x cube and then add here. This process is familiar to you. You guys already know this process. So very basic division process. Okay. Now there's a identification and characterization. So degree. So degree of polynomial is the highest power of variable. We already talk about it. That whatever the highest power of your exponent, that power is going to be a degree of polynomial. And according to degree, we classify our polynomial into constant, linear, quadratic type of. Okay. Another one is leading coefficient. So the coefficient related to the higher power of polynomial is known to be the leading coefficient. Leading coefficient is play a very key role in for determining the end behavior of your polynomial. Okay, so we'll come that to later. Now zeros and roots and x-intercepts are all the same. Zeros or roots are those values of x where your polynomial becomes 0. That means those value of x where p of x is equals to 0. The same thing as we discussed in quadratic. Right. And the turning point is where the polynomial changes its behavior. What do you mean by turning points? Turning points. So turning point is those points in which either the polynomial first get increasing and then then it will decreases. Then such point is known to be a turning point, or the vice versa type of situation. Either it will decrease first and increase later. And such kind of point is also known as turning points of polynomial. Okay. So turning points where the graph changes direction. By changes direction means either increasing to decreasing or decreasing to increasing. That is where the derivative is 0 or undefined. You will learn about this derivative term in 5th week or maybe later, 5th or 6th week. Okay. You will get your hall ticket sooner, maybe tomorrow or day after tomorrow. On Sunday you have exam, right? So you will get your hall ticket before Sunday. Now behavior at x-intercept. So what happen if we have polynomial? Then there are 3 type of behavior could happen. So no, mainly either you could cross the x-axis or you will just touch the x-axis and return it. What do you mean? So let's say at x is equals to a, my polynomial p of a is equals to 0. So that means a is the root of polynomial. Then what happens? So at a we could have two types of situation. Either the graph of polynomial will cut the x-axis and become I mean from positive values to negative values we will get. Such type of scenario could happen, or we can just touch the value a and return it in the same sign with the same sign. I mean already first we have positive and then we have positive. So such type of situations could happen. So using those situation, we can find out the multiplicity of root. By multiplicity means the power of x minus alpha in the polynomial. Okay, so you come to multiplicity after the end behavior. Okay. So now what is the end behavior of polynomial? So end behavior of polynomial is when we take very much larger values of x, how does the value of px will change? So that means if I tend my polynomial x goes to infinity, then how my polynomial p of x will change? Okay, so this end behavior is actually depend on the leading coefficient of yeah, multiplicity I haven't explained yet. Well, yeah, we have to explain. Right. I'll come to multiplicity at turning point. Okay, fine. First, let's go with the end behavior. So what happens if I'll take my x goes to infinity? That means I'll take much larger and larger values of x. How does my p of x will affect it? Okay. So the end behavior of any polynomial is actually depend on leading term. But what do you mean by leading term? Suppose your polynomial p of x is an x to the power n plus an minus 1 x to the power n minus 1 plus and so on plus a, right? So if your leading term an is strictly greater than 0, then as x goes to infinity, your p of x is also goes to infinity. Why does this happen? Well, this happen because your a and x to the power n is there, right? So this x to the power n has the ability to dominate your nature of polynomial, because all the powers have lesser I mean all the powers of x will be less than this n. So that means this is the greatest I mean largest power of n, largest power of x present in the polynomial. So if your leading term is positive, then as x goes to infinity, your polynomial also goes to infinity. And if your leading term is negative, then x goes to infinity, your polynomial will go to minus infinity. Okay. Yeah. I'll do here. So suppose an is your leading term. So if an is strictly greater than 0, then as x goes to infinity, your p of x will also go to infinity. That means this will happen. X here x is going to infinity and your p of x is also going to infinity. Here another situation, if your an is strictly greater than 0, that means leading coefficient is x is your input, right? Whatever value you will take here, the x-axis. Okay. And as if your leading coefficient is positive and x goes to minus infinity, then your p of x will also go to minus infinity. Such type of this, sorry, not this. Such type of thing, right? So x is going to minus infinity and p of x is also going to minus infinity. Okay. Now, if your leading term is negative, an is less than 0, then all the behavior will change in the reverse direction. That means if leading term is negative and x goes to plus infinity, then your p of x will go to minus infinity. And similar thing happen with minus infinity also. If x goes to minus infinity, then p of x will goes to plus infinity. Okay. Yeah, sure. Yeah, but here we have to consider the degree of polynomial also. I mean, even or odd degree also. So this situation happen when your n is odd. N is odd, right? So make a chart here and try to understand the end behavior of polynomial. Yeah, in the qualifier example, there will be a virtual calculator present on your screen. Okay. So if n is odd, and an is strictly greater than 0. So then as x goes to infinity, p of x will also goes to infinity, right? Right. First thing is this again. If n is odd and your leading coefficient is strictly greater than 0, then as x goes to minus infinity, p of x is also goes to minus infinity. If we have even degree polynomial, so if n is even and your leading term is greater than 0, then both things, that x goes to infinity, also p of x goes to infinity, and x goes to minus infinity, p of x will also goes to infinity only, because every even degree polynomial will have either both sides will go to plus infinity or both sides will go to minus infinity. You can use this chart, right? So even degree polynomial. So even degree polynomial behave in this way. Either they will rises to infinity in both of the from both of the directions, or they will decreases their values when we move along both directions. I mean right side also and left side also. Okay, but the odd degree polynomial behave a little bit different from even degree polynomials. So you can observe in this figure that when x goes to infinity and if power is and if the leading coefficient is positive, then p of x will also goes to infinity. Okay, so now let's come to multiplicity of root, because here I haven't put the multiplicity. Okay. Yeah, at the last point, I told the end behavior of polynomial. So what I want to say that if n is odd, that means when the leading what we can say leading power of polynomial or the degree of polynomial is odd, and your leading term is greater than 0, then as we move toward the right direction, that means as our x goes to infinity, our polynomial is also goes to infinity. And if our n is odd, and an is strictly greater than 0, then if our x goes to minus infinity, px goes to minus infinity. But the even degree polynomial behave little bit different from the odd degree polynomial. So even degree polynomial में अगर if your an is strictly greater than 0, then as x goes to minus infinity or plus infinity, in both cases my polynomial will go to plus infinity. So I'll write it down for same thing for when you have a what you can say the negative leading term. Okay. So in place of positive, if we have a negative sign here, then as x goes to infinity, my p of x will go to minus infinity, or in odd degree polynomials. Similarly, as x goes to minus infinity, my p of x will go to plus infinity. In even degree polynomial, if we have a negative leading term, then as x goes to infinity or minus infinity, in both cases, my p of x will go to minus infinity. So just try to understand this chart, this thing, these two situations. These situations define the end behavior of your polynomial. Yeah, I have some practice questions for you, so you can solve that also. Okay. Now let's move toward the multiplicity. Multiplicity of zeros. So what happens whenever you have zeros at x is equals to a, if p of a is equals to 0, then x minus a will divide p of x, right? So that means x minus a will be a factor in p of x. So that means if you collect all the zeros of polynomial, then p of x can be written as in this way, that x plus a1. Let's take it minus here only. So x minus a1 to the power r1, x minus a2 to the power r2, and so on, x minus an to the power r. So that means every polynomial, every polynomial we can factor it out. In quadratic also you learn that x minus 2 square, we can write out this polynomial x square plus 4x plus 4, right? So this is one polynomial and this is a factorized version of that polynomial. So that means every polynomial can be decomposed into some factors, right? So whatever the power of that factor will come, that power is known to be the multiplicity of that 0, multiplicity of that root ai. For example, here r2 is the multiplicity of, after this only, multiplicity of a2, the graded assignment you have, right? So this is called the multiplicity of root. See, and suppose you have given a graph of a polynomial, right? Suppose this is your graph of my polynomial. Okay. So this graph will cut at so many points, 1, 2, 3, 4, 5, 6. So whenever you have a root where the graph cuts the x-axis and from positive to negative or negative to positive, I mean, it will change their sign in such type of roots, right? These roots will always have odd multiplicity. Always have odd multiplicity. So if someone asks that what are the possible multiplicities of these root, suppose this is x is equals to -2, then the only choices are odd multiplicity, either 1, 3, 5, and all things, right? And whenever you have such kind of the behavior, that the polynomial won't changes its sign. By changes its sign means पहले भी positive और बाद में positive, right? So if we have such type of thing, then at those zeros, we have an even multiplicity. Those zeros will always have an even multiplicity. Okay. This concept is clear about multiplicity. By looking a picture, I mean, by looking the graph of polynomial, we can easily say that this root can have an odd multiplicity or this root can have an even multiplicity, right? See, what happens whenever you have such kind of behavior, that first the polynomial is on the, I mean, in the upper half of our graph, in the positive y-axis place, positive y-axis space, and after cutting the 0 and after touching the x-axis, it will move toward the negative region. In such kind of row, I mean, at that point, those kind of roots will always have negative multiplicity. That means either they will come 3 times, 1 times, or 2 times in the factorization of one, right? And whenever you have such kind of thing, when the positive to positive or negative to negative, and such kind of thing, negative to negative, these type of root will always have even multiplicity. Okay. Yeah. Okay. So that's all I have to discuss from the theory. Roots portion. So I told you when it will have even multiplicity when this thing happens. That positive to positive or negative negative. Then only we have even multiplicity. Okay. So turning point is basically those points which from where the polynomial change its behavior. I discussed turning point, I think. Huh. Yeah, I'll share the PDF in case anyone teaches them. Okay, so I'll unmute you guys now, one by one, and tell me your doubts. So Pushkar.
Yes, ma'am, I'm having doubt in graded assignment.
So post your graded assignment now in chat box because it goes up now.
Okay. Give me a second.
Abhinav, do you have any doubt? Abhinav? Hello? Okay. So,
Hello?
yes.
Ma'am, can you just show me the
Uh, your voice is not clear.
Now I posted it in chat. You can please check.
Yeah. Okay.
hen behavior, the chart? Ma'am,
Also
not this
write
one,
it one time.
the graph one.
This one, right?
Not this graph one.
Yes, ma'am.
Hello?
This one.
Oh, this graph one.
Hmm.
Okay.
This one. I am
The
having
hen
doubt on this
behavior.
question.
Mhm. So this graph one, right? So let
Yeah,
me first
yeah, ma'am, hen
discuss
behavior.
this doubt of Pushkar.
Okay, okay.
And behavior na.
Ma'am, actually, I am getting the answer 34, and in answer it is written 35. And I had solved it multiple times, 45 times, but I'm not
So
able
A
to
is
get the
equals to
answer.
x belongs to natural number, B is x. X is a rational number. Okay, find the coordinate of the set A minus C intersection. Okay, so we have to do A minus C and then intersection with B. Okay, what is B? So B is basically this open interval -5 to 105, right? And A is all natural number between this those intervals, right? So here you don't have to consider -5 and 105.
Yes.
So first we have to subtract C from our set. So in C, you observe that X is between 10 to 80. So how many natural numbers are there? It's 80 is considerable. So from 11 to 80, you can find it out. So I think there's 69 natural numbers, maybe.
Yes. Set A
From
consists
11
of
to
all natural number. Ma'am, A consists of all natural number 1 to infinity, and B is -4 to 104, and C consists of 11, 12, 13, 14 to 80.
So
Okay.
I'm asking that how many natural numbers are there in C? So from 11 to 19, we have 9 natural numbers, and from 20 to 80, we have 60 natural numbers, right? 20 to 29, we have 10, and then 10, and then 10. In such a way, we can. That means we have 69 natural numbers, right?
Yes.
Am I right?
Yes.
So if you delete these natural numbers from here, what you will get A minus C is nothing but all those natural number except these 69 ones, right?
Yes,
And then you
1
have
to
to
10
intersect
and,
with B.
yes, ma'am, 1 to 10 and 81 to infinity.
In intersection, yeah, this whole this is actually 10 to 80, right? This is a subset of this thing -5 to 105. What's the answer?
No, answer is given 35 and I'm getting 34 because I'm not including 105. So I'm getting 34.
105 shouldn't be there.
Yes, ma'am. I'm getting 34.
Ma'am, are we going to include 0 in natural numbers? Then I
No,
think
it is mentioned in the portion, I think. But
is that mentioned in that portion?
no, it's not
So if
mentioned in
0
this
is
question.
included, then
But
No,
it is
ma'am.
mentioned.
Professor has
It
mentioned
but
mentioned.
if
that
you
0 should
include
be
0, you will
included.
get 35.
Mentioned in the question.
Yes, ma'am. I had not
Okay.
included 0 because we generally don't include 0 in natural number.
No, ma'am. Professors have told us that
No.
we should include
Professors
0.
say that. Giri. So we have to include 0. Then your answer will be correct.
Okay.
Okay, fine. Fine, it's clear, right?
Yes, ma'am. Thank you.
Hello.
Yes.
Ma'am, I have a doubt in the graded assignment question.
First we'll yeah, please post it in chat box. First I'll discuss this graph and behavior.
Yeah,
Okay.
ma'am. The end behavior, can you show it? I have a doubt over there.
Mhm. This is your question, right?
Ma'am, I'm not asking any of the question. I'm asking the end behavior such as the quadrant basis, like A is greater than
That chart.
0.
He's asking for that
Chart,
chart.
yes.
Okay, so you can refer this chart, right? This chart. We simply say that whenever you have a odd degree polynomial and you have a leading coefficient positive, then polynomial will go in infinity as x goes to infinity. Similarly,
So
when you have
actually
odd
here,
thing,
here actually can we say where is it is increasing and decreasing by looking at the polynomial. So if it's the polynomial y equal to x cube, so whether it is increasing or decreasing, how can we say? So it is from the
so
x
why is it?
quadrant. Yeah.
So you want increasing or decreasing thing,
I mean, yeah.
right?
I mean,
So
yeah.
x cube
So
you can say x cube is
yeah, y equal to
this
x
is
cube.
x
So
cube, right?
that
So I mean it's
yeah,
increasing.
it is increasing. But
So
from
it's
the negative x quadrant, it is
increasing.
decreasing, right?
Yeah, I mean as x goes to minus infinity, this will goes to minus. But increasing behavior, I mean particularly increasing, they say na, then you have to just look this thing that we say that px is increasing. If it is p of x1 is less than less than equal to p of x2, for all x1 is less than equal to x2. So here this thing is happening, right? Whenever you take x1 less than x2 in x cube, you will get p of x1 is also less than x2. You will take x2 here, x2 is less than x1, right? So your p of x1, x2 is again less than p of x. So that's, I mean, this increasing, decreasing thing is little bit different from this NBA. Okay. Is it clear now? This is the thing. If you want to say that your px is increasing in some interval, you have to check this thing that whenever you take x1 less than or equal to x2, your value of polynomial should be less than equal to I mean p of x1 is less than equal to p of x2.
Ma'am, is this for strictly increasing?
It's actually depends on the terminology. It will say, some people say when we have strict inequality, they say strictly increasing, but it really you can say increasing only. Is it clear now, or you still have a doubt?
No,
Hello.
Ma'am, I have a doubt. Can I post my question in the chat box?
Yes.
Just a second. And I have question for this increasing and decreasing. This was not covered in the lectures that were provided to us. So is it going to come in the exam, in the qualifier exam?
See, yeah, increasing, decreasing, we haven't covered any. I think we haven't covered, but you can easily refer to this thing. I'll just explain once again. See, whenever you have a function f, right? So f is said to be increasing if you will take the value x1 less than equal to x2. That means the input value is less than. I mean, you will take two input. One is less than another. Then it should imply that f of x1 is also less than equal to f of x. That means this inequality will be preserved, right? If you take smaller value as an input, then the corresponding output value is again smaller than the corresponding output to the different point, right? So in this case, we say that is increasing. You can judge increasing, decreasing by the graph. Suppose this is your graph. Then you can observe that after this point, let's say this is x is equals to 8, right? So after this point, you can easily say that the graph is increasing. You know, the graph is actually giving you this condition. Because if you take any x1 which is less than x2, the corresponding value of a function f of x1 is again less than f of x2, right? So using the graph, you can easily say whenever it is increasing or decreasing. Now it's clear. And similar thing with the decreasing. In decreasing, you have to take the reverse inequalities.
Okay, ma'am. Thank you.
Ma'am, can you
Yes.
explain the chat box questions, ma'am?
Ma'am, I had sent you
Sorry,
two
what?
screenshots in the chat box as a screenshot. Screenshot on a file type.
Vedika's
That's my
this
question
file.
which I posted.
This one?
Yeah,
ma'am.
it's the one which I posted. I am waiting.
Wait,
I just want to see. Could you please explain this? Like maybe because I actually wanted to post the previous question also, but I'm not able to take a full screenshot of it.
See, this
Ma'am,
question is a
everyone
great.
sending
First,
one repeated question, ma'am. Can you explain that also?
okay. See, what we can do. Just raise your hand. Whoever send a question in chat box, I'll go by one to those these questions, right? Just raise your hand if you have sent, because if you send the question and there is a lot of chat going on, then I can't get to that question particular. So first I'll discuss this question, and after that I will take name that person can send his or her question in chat box. Okay, is that fine? See,
Yes.
here they have given a graph which represents the polynomial. First thing is multiplicity of -1 and 1 must be same. See, here -1 at -1 and 1, the polynomial is cutting the x-axis and changing its sign. That means positive to negative or negative to positive. So that means surely that the -1 and 1 will have odd multiplicities, but not necessarily the same, right? It could happen that -1 will have one multiplicity, but 1 could have 3 multiplicity. In that scenario also, polynomial will change its sign from positive to negative. That means this option is not okay, because they are having odd multiplicities, but not the same odd multiplicities, right? Okay. Now here they say px is increasing interval 3 to infinity. Where's 3? So this is 3. So you can easily see here that the graph is actually a kind of increasing behavior, right? So this option is correct. Now you guys are familiar with increasing thing. Increasing means if you take x1 less than equal to x2, the value of output should be less than equal to the value of that different and
Ma'am,
corresponding
can you one
inputs.
time again repeat option number 2?
Yeah, so option number 2, what happened? In option number 2, you can observe the graph that it's a increasing kind of a graph.
For odd degree polynomial, if x is increasing, then
So say 3 to infinity, no?
Yeah, so it will going to infinity, but it is increasing, right? I mean, it's
It's going on the right.
it's going up as x going to infinity, right? So this is a kind of
No,
increasing.
what is
Ma'am, in
strictly
option 1,
increasing?
both also odd
Increases.
degree only, no, ma'am. Then why,
What
ma'am,
is
it
it
is not there?
strictly increasing?
Strictly increasing, we have strict sign. I mean, we don't have the same output. For example, if you take constant function, then that function is not strictly increasing. Don't worry about strictly increasing. They won't ask about strict thing because it's a bit confusing about terminologies. So just this is I mean, you can easily see by the graph that as you take x1 less than equal to x2, obviously your p of x1 will be less than p of x2. There
But there
will
are
be minor
questions.
change, but yeah.
Strictly
About
increasing
strict thing.
questions are there. Yes.
Okay. So in strictly increasing, what happened? That strictly increasing basically follow this rule. That if your x1 is strictly less than x2, then p of x1 is strictly less than p of x2. This should happen. But if
Ma'am, in
you
first
consider
one,
the
both is
constant
also
function,
odd degree only, no, ma'am.
sorry, what?
In first one, both is also odd degree only, no, ma'am. Positive to negative and negative to
Odd,
positive.
right? Odd, but not same. In odd, we could have one 1 multiplicity, 3, 5, 7. They are saying must be the same. Same means exactly same. But -1 could have 1 multiplicity and 1 could have 3 multiplicity. Then also this scenario could happen, right? So that's why this option is not. It's not exact same. They will have odd multiplicity, but not exact. Yeah, but the constant polynomial, if you have constant function f of x is equals to, let's say, 8, then you know that whenever you take 2 is less than 4, but f of 2, which is 8, is equals to f of 4. That means not strictly increase. So in strictly increasing case, we have strict inequalities. Strict less than, right? Is it clear now?
Ma'am,
What
if
the third and fourth
multiplicity
option?
given as 7, so how can we solve it?
Sorry, what?
If the
Say
multiplicity
one by one.
is 7, so how can we do?
If the multiplicity is 7.
Yeah, or 5, something.
Then also this kind of thing happen. That's why the first option is not true, not correct. The second one is true. The total number of local minima is 3. So minimum point you can easily find out, right? This is a local minimum. This is a local minimum. This is a local minimum. So that means there are 3 minimum values: 1, 2, and 3. That's why this option is also correct. Am I right? This
What
option is
is
correct.
local minimum?
Uh-huh.
Local means?
Local minimum means not you'll just consider little bit interval here, the small interval. In the small interval portion, if it is becoming like this kind of shape, this is called the local minimum. I mean, in the small neighborhood, in the small interval, you have a minimum.
Ma'am,
We
how
have
can
a
we find
minimum.
local minimum?
Just by looking your graph, you can easily check that if you consider this small interval, then in this small interval, this is the minimum value of a function could take, right? So that's why it's a local minimum.
So only in the below
Again,
two
is
quadrants the minima will be applicable, is it?
In the very small neighborhood. So if you here you can consider this much large neighborhood. In this much large neighborhood, this is the point where we have a local minimum. Local minimum is smallest value a function could take, right? So this is the smallest value
Ma'am,
this
then
function
4
can
are
take
there,
in
no,
this
ma'am, in
small
the
interval.
second
So what
quadrant
is
also.
not local minima?
This point is not local minimum, right? If you consider any small interval, this value won't be the minimum value of function could take, right? This type of thing.
Okay.
This value can't be a local minimum. Is it clear
So
now?
local minimum means the downward parabola, I can say the least point, right?
Such type of figure you will find.
Yes.
And this is local maxima type of thing. Because here you are
Yes.
getting
Okay, so those are, so we have two local maxima.
Yes.
Okay. So now turning number of turning points you can easily check. Okay. This is one turning point. This is a one turning point. This is a one turning point. One turning point. Right. So number of turning points you can. So it's not it's 5, 6 are there, right? 1, 2, 3, 4, 5, 6.
Oh, even the origin we consider as this turning point, is it?
Sorry, what?
Even near the origin, that small one is also considered a turning point.
It will also consider
that will also.
turning point.
Because I always thought like there is a trough kind of
Because
thing.
because here we have decreasing to increasing. So turning point means the function should increase first or decrease. I mean increase first then decrease, or decrease first then increase. Change its behavior at that. So this also turning point 0.
Sorry, how many turning points are here?
Can you please repeat
6 are there,
this
right?
last option?
I missed that everything. How it is 6?
Sorry, what? See.
How it is 6?
Just wait. See, what is turning point? Yeah. Turning point, right? So turning point are those points where either your polynomial first decreases and then increases, decreases first and then increases, or increases first and then decreases. Right? Increasing first and then decreasing. Such type of points are known to be turning points. Here, This point you can easily see that first increasing then decreasing. Here also you see the decreasing, increasing, decreasing, right? So there are 6 of them.
Oh, okay. That's 4, 5, and 6. The last.
1,
Okay.
2, 3, 4, 5, 6, right?
But ma'am, it
Correct.
cuts the x-axis at 6 points. The graph cuts it at 6 points. So ma'am,
Those
the
are
turning point
zeros.
must be cuts minus 1. So it should be 5, right? Like, with that logic.
Degree minus 1.
No, no, no.
Ma'am, it's degree minus
This is
1.
not a
Degree
thing.
minus 1 is the turning point.
See, here we have right that turning point occur where the polynomial changes direction, right? For a polynomial of degree n, there can be at most n minus 1 turning point, right? This polynomial here, we don't have a specified degree. This polynomial could have any degree, right? Because it's just a graph.
Sorry, ma'am. Got it.
Yeah.
Ma'am, x is equal to 0 in that x. What is the root over there? Say x square, right?
X is equals to 0, no? It could be square or
X square, right? Yeah, yeah. X.
power or
Yeah,
6
2 or 4, any power, yeah.
Yeah, yeah. Okay,
even,
okay.
even will be that.
Yeah,
Ma'am,
even. Yeah.
Ma'am,
if the graph
ma'am, one question, that interval, there is one question in our assignment, graded assignment. I just pasted. So a equation given and it asks that the characteristics on this interval. So how to find it, madam? I mean that.
Characteristic. I mean,
Yeah, I mean that whether it is
What?
increasing and decreasing in this interval or not.
Are you talking about
just
end behavior?
see,
Yeah, just I put.
increasing, decreasing issues.
Yeah, I just put into the chat, ma'am. Last one.
Kaushik.
Yes,
Yeah.
yes.
Brother, you can ask in Hindi if not comfortable in English. No problem.
No problem. Yeah, anyone can ask in Hindi.
Yeah, you can ask, ma'am will teach in English, but you can ask in Hindi.
This is your question, right?
Yes, ma'am. Correct.
So the height of roller coaster and the given things deliver T is in the time second. Roller coaster. Okay, so what you have to do? This is a graded assignment question.
Yes.
So here, what you can do, since it's a very complicated question, right? So what you can do, you can plot this polynomial using desktops, right? So if I plot this polynomial,
Ma'am, can you please tell how just we can solve and calculate the turning points of this polynomial?
this the large one.
If anyone has the graph, share that now.
Yeah.
But I think in the exam we cannot use the Desmos, right? So how to
So
solve
we
that time?
won't give such complicated polynomial.
No,
We'll just give
this
simple
question will
polynomial.
never come
Just
in
take,
question.
you have to do long division of that cube
Will
wala to get its root.
No, it's easy question.
Sorry,
You can
what?
do that.
You'll have
Wait a
to
minute.
take the long division of the t cube wala equation to get the roots of the t cube wala equation, and have to plot all the roots with the degrees.
Can directly
Because
put it.
these are simplified, so you can find out the roots here. That minus
Just take the
5,
values
5,
of t.
minus 1 and 1.
You can
And then
easily
you
draw
have
the
to find out
graphs
this.
using these characteristics.
Right. But here we have a equation. So we have to find out the root of this cubic.
Yeah, ma'am. I also had a
Then
doubt
I
how
can
to find
easily
the
plot.
roots of these cubic polynomials are to the ray.
See, there is one method for finding cubic polynomial, but that method is, it will take so much time. One thing is you can get it by
Can we
intuition that here it's a 0.0 cube 0.35 minus 3.5 and plus 10, right? So here this is there, right? So here somehow I get the intuition, okay, this is 0.35 plus 3.5. So if I multiply by 10, I'll get 3.5 minus 3.5, right? And here also, if I take, but this is 0.01. So I think I could take under the root of 10, but that won't work. So
Ma'am, your voice is breaking,
cannot
ma'am.
hit and try.
Excuse me, ma'am.
Now?
Ma'am, your
Yes.
voice is not.
Hello? Am I audible?
Yes, ma'am.
Yeah, ma'am.
Ma'am, can you get to the last question of
Ma'am,
that graph thing?
starting.
Last one. One.
Excuse me, ma'am. Hello, ma'am.
Yes.
Ma'am, if you don't mind, could you explain
No.
the graph question? Could you explain the first option once again, ma'am? Like, why is it wrong actually?
Ma'am, in this question, suppose the graph is given of px. So is px odd or even? There are some questions like this, or like it can be neither odd nor even. So, ma'am, how to find those things?
See, this someone asked about multiplicity. Here, multiplicity -1 and 1 is odd. That's why this is not.
Actually, this question is
Am I audible?
conflictable.
I think that there's
Question has
net
been
issue.
removed. Your voice is breaking.
There's some net issue. See this question. I'll think using Desmos will be much easy, but the explicit roots. See, first let me go one by one. Yeah, I'll share the session PDF. So for finding the cubic polynomial roots, you can use hit and try method. Okay. So hit and try we'll try to put some values x equals to 1, 2, 3, or some observation used based on that expression. And after that, we will divide if some of the roots, if we get one root, then we'll divide the whole expression by that root and get a quadratic equation and get a particular solution for particular root quadratic equation. So you proceed using this way only. The other way is very long and I don't also
somewhere I
remember
have seen
formula.
that how to optimize this heat and run. Like we have to see that what is constant. It is here it is 10. So find out all the factors of 10 and put that factors into the equation and check if it is 0. When it is 0, consider that as a
So you
root
have to do
and then
something.
2.
And then you
That will reduce
That's
our
how
heat and run combination. So
Bro, can you repeat again?
okay. So what I have read, if you see the equation of this cubic, there is a constant term as plus 10. So minus 3.5 t plus 10. So that 10, whatever may be the constant, you try to find out all the factors, like what a 10 is divisible by 1, 2, 5, and 10. So these are the factors of 10, plus or minus. Then put plus 1 into that equation and find out whether that equation is giving 0. If not, then take minus 1. Then if it is not, then go for the 2 because next factor is plus 2. If it is there or not there, like depends upon that. If it is plus 2, then x plus 2 is your actual that one value what ma'am has
actually
shown.
it's a very
So
Ma'am,
long
divide
method.
them.
That he
the
is
roots
saying.
are coming out as -5, 10, and 20 of this
Not
quadratic thing,
20. 20 is
cubic
what
thing.
-5,
showed
10,
you.
and 20.
Yeah, so you can take
Yeah,
long
ma'am.
division, like divided by x plus 5, long division, and then whatever we get, we
And
can
then
take 10 and 20
whatever
as
is
the
the
roots.
Ma'am, can you take my problem which we discussed earlier?
yeah. See, what's the just mute everyone. I'll whose voice this is? Just telling whose problem? Okay, let's move
Sent you
one
in the
by one.
chat
So
box.
Aniruddha,
What is
yeah, okay, you have
Yes, ma'am. Hello.
what's your doubt?
Ma'am, yeah, I had the same doubt in the roller coaster question.
So you can put here the all the roots and find out. I mean, just by finding the graph, you will get the answer, right? You're
The
not
point
audible.
p square something, that question. This one, yeah.
This one.
Yes, ma'am.
This ninth one.
Yes, ma'am.
So now let's solve ninth one first.
Ma'am, I gave you the roots so you can plot it with that 5 minus 5, 10, and 20. So cubic graph.
This cubic polynomial has 5, 10, and 20, right?
Minus 5.
Minus 5, 10, and 20.
Oh.
See. So what we yes.
Yes, ma'am. Like finding the roots, I struggled with that.
You are struggling with finding the roots, so you can
For
use
this portion
the
only,
hit
ma'am.
and
The
try
first
method.
portion. The first portion alone. The others we can find out. For this one, like how could we couldn't we didn't know how to go about.
I also
See,
had a doubt here, ma'am.
Ma'am, can we
This
multiply
question
any
won't come, don't
constant
worry.
See,
Ma'am, it's plus 5
whenever
only,
you have a
not 9.
cubic
Plus
polynomial,
5. Plus 5, 10, 20.
okay. So whenever you have a cubic polynomial, na, you can use hit and try method. Yeah, plus 5, right? Okay, thank you. So you can use hit and try method, or there is a one long division method for solving this cubic polynomial. You can YouTube it because I also don't remember that. But I mean, there are several steps to follow to finding the root. But we mostly use hit and try method. I mean, by observation, you'll get the answer, get the feel of this will work. For example, here I get the feel that if I could make this term to be 10 and this term to be 3.5, then it will be solvable. But turns out that
Ma'am,
okay, so
can we also substitute values for t?
Ma'am, I have shared the
0,
solution for
minus
this
1,
particular question in
something
chat.
like that, and then we can find out. But that will be like too long, no? In the examination, if they're going to give like this.
right. We obviously we will take. I mean, we'll keep in mind that the finding root thing won't take that much long. Here we have to put all the values. First, I have to substitute 10 here. Then the 10 cube will be
I have shared the
10
solution
will
for this
become if
question
I
in the
put t
chat
is
box.
equals to 10. Yeah, someone shared. You can download it. He uses the long method, the long. Right. So this is one that first you will take out the common and do these kind of things. So you can refer to this solution for finding
Good job.
cubic roots.
Thanks,
But
dude.
But this question,
this is the long method
please
you
don't
have to
recommend. Okay.
This question will never come
Yeah,
in
we won't
45.
ask such type of thing. Obviously, we
This
will
Okay.
keep in mind that you have only 1 hour. We won't ask anything which will take 1 hour just for
this
this
question will
computing.
never
We want
come.
to evaluate by your theory, not
Okay.
by
Yeah,
your calculations. Okay.
otherwise it will make it will
Ma'am, I
make us to
had
sit
one
What
in
you
doubt,
will do
roller
ma'am.
is
coaster.
in place of this, yes. What's your doubt?
Ma'am,
Ma'am, I
again,
had already posted it. Again, I'm
Ma'am,
posting it in the
excuse me,
chat,
ma'am.
ma'am.
Hello, ma'am.
Okay, this
I put
long
it in
one,
the chat.
Nindya.
Ma'am,
Yeah,
could you actually,
just now I put it.
ma'am, could you explain the previous question once
Wait,
again, the graph wala
wait.
question?
Hello, excuse me, ma'am.
We explained it. What's your doubt? I'm just
ma'am.
Ma'am, how to find
okay.
out
Wait.
whether if
Ma'am, in the previous in this question, ma'am, like could you once again explain why does the multiplicity of minus 1 and 1 does not like are not same actually? I still get the part.
Bro, it can never be
We
same.
will get
This is a very
odd.
conflictable question.
We get odd, right? Odd could be anything 1, 3, 5, 9, and so on, right? So that's why it's not same.
You
Okay.
can't
So
say
I'll
that both are
now
same.
see.
Ma'am,
Now I'll mute
actually,
everyone. Just wait a
one of
minute.
the previous session,
Yeah.
Asit sir told that when we get an option like must be, should be, then you should not select it because it will be wrong. If they have given can be, might be, then we can select the option.
This is
Here,
just because
this
See, it is depends upon the question,
we
right? If
can't
it is a
consider.
multiplicity odd means it is must be.
Right.
Yes.
Actually, it depends on the question's content, whatever they say. But here you can easily see, right? It's odd. That means it can't be more. I mean, it can be 1, 3, 5, anything. Still, we have that nature. Okay. Now I'll mute everyone. I'll come one by one to everyone. Otherwise, we can't go. So I'll first Now come to Anirudh. Anirudh, what's your doubt now? If you don't have doubt, you can lower your hand. Anirudh, hello. Am I audible? Hello, am I audible?
Yes, ma'am, you are audible.
Yeah, so you have any doubt?
Yeah, somebody posted that question, which of the following function first increases and then decreases in the intervals?
Which one you can post again in chat box? Can you do that?
Just a minute.
Uh, be quick. Yeah.
1 minute. I'm taking the screenshot and then.
Got it. Someone shared the screenshot.
Is it?
Yes.
Yeah. Yes, ma'am. Second question.
This Arun have shared. So, which among the following function first increases and then decreases? See, here you have already given all the factorial, factorized polynomials, right? You can just plot it to your polynomial. For example, if I want to plot this polynomial, let's suppose I have to plot this p of x is equal to, yeah. Give me a second. Okay, so I'll explain naturally and then we'll take a polynomial. X square, x minus 5, x plus 2 cube, and multiplied with x minus 1. Right, suppose this is your general polynomial and you have to plot this polynomial. What you'll do, first mark all the zeros. So from here I'll get minus 5, from here I'll get 5, from here I'll get minus 2, from here I'll get 1. Right, and I also get multiplicity. So I have 5 with multiplicity 2. I have, minus, am I audible? I think my internet got minus 5 will have multiplicity 2, 5 will have multiplicity 1, since I have x minus 5 to the power 1. Okay, and minus 2 will have multiplicity 3 and 1 will have multiplicity 1. Right, so just mark all the roots. So minus 5 will be there, minus 2, 1 and 5. Right, now if you have to plot the polynomial, consider the nature at every root. Minus 5 will have even multiplicity, so that means polynomial will look like something like a parabola type of thing, right? At minus 2 we have odd multiplicity, that means polynomial will change its sign from positive to negative. Why positive to negative? In previous root we see, now here also depend that we have to start from here or here, because here the leading term is positive, right? So that means the polynomial will go and you can easily check that this even degree polynomial. Should not refer it. So this is px. So px, degree of px is 6. That means even. And there is a positive sign here. So you can easily check that from here the coefficient of this polynomial will be positive. Why it is positive? Because if you multiplied, you'll take x square from here, x from here, x from here, and x cube from here, and x. And you multiply all those things, you will get positive leading coefficient. So this is 2, 1, 3, and 1. So I have a 6-degree polynomial, right? Why 7? Oh, I missed. I changed. Sorry, It's a 7 degree polynomial. That means an odd degree polynomial, and its leading coefficient is positive. So whenever we have a leading coefficient is positive, we have to go with that direction. I mean, we have to consider the n behavior also. So it's an odd degree polynomial with a positive leading coefficient. So that means as x goes to minus infinity, my polynomial will also go to minus infinity. So that means my polynomial will start from here and then it will cut to -5, go to -2, then go to 1, and then we have to go to 5. Now here at -2, I have at -5 also we have even nature. So that's why at -5 my polynomial will go and touches -5 and return in the same direction. I mean in the same space, negative y-axis toward negative y-axis. Okay. And at -2 I have a odd degree, so that's why it will cut and go up because we have a 3 multiplicity at -2. And then again at 1 we have one multiplicity. That means again it will cut the x-axis and return into the negative y-axis space, negative integer space. And again at 5 we have one multiplicity, so that means again my polynomial will go and cut it and go in this direction. So this is a rough sketch of the polynomial. Okay. So from here you can check your behavior, because if you consider this line, suppose this is my this is my x is equals to 3. So from 3 to infinity, it's an increasing thing. But from 1 to 3, it is decreases and decreases. And I mean, now by using the plot of polynomial, you can say whenever when it will increases and when it will decreases. Okay. Yeah, it starts below x because it's an odd degree polynomial and we have positive leading term. That's why. That's why we have to start with see, this is an odd degree polynomial with positive leading term, because if you consider the sign of x to the power 7, then we have to took x square from this bracket, x from this, x cube from this, and x from this. So at the end I will get x to the power 7 with some positive term. That's why it's a odd degree polynomial with positive leading coefficient. That's why px will goes to minus infinity as x goes to minus infinity, and because of this reason we have to start from negative side. Okay. Please raise your hand if you want to unmute. Okay. So I think that's clear now. So now I'll move to next person. Divya, what's your doubt?
Ma'am,
I'll share the PDF at the end only.
Send a question now in the chat box.
Yeah, please.
Can you please explain how to solve this particular question?
This is your question, right?
Yes.
Okay. So what does here they say that f and g are two functions, fx is this, g is this, respectively. Choose the correct answer. I was strictly increasing 10 to. Again, we have to do go with the same thing. Fx is x cube minus 8x square plus 7. Now here you can easily observe that if you put x is equals to 1, what you will get f of 1 is nothing but 1 minus 8 plus 7. That means 8 minus 8, which is equals to 0, right? So that means 1 is the root of this quadratic equation. Now what you will do, you will use the division method to reduce this into from cubic to quadratic equation. Okay, so if I divide x minus 1, if I divide x square minus 8x square plus, x square minus x cube minus 8x square plus 7 with x minus 1, what I'll get, I'll to take x square here, then only I'll get x cube, and then minus of x square, and then minus will become plus, and this will get cancel out. And here I'll get minus 7x square plus 7. That means x square minus 7 I have to do, right? Then I'll get only x square plus 2. So that means this cubic equation will reduces into x minus
X
1
minus 1
and
and
x square
x
minus
square
7.
minus 7. Okay.
And this also
We
can be
go
reduces into x plus root 7 and x minus root 7. Now what we can do, we can plot it, right? So we have again, this is a odd degree polynomial with leading coefficient positive. That's why we have to start from this region, right? And we have roots x is equals to 1, x is equals to root 7, and x is equals to minus root 7. So we'll go up to minus root 7 first. Again, the minus root 7 will have odd multiplicity 1. That's why it will go up, come down at x is equals to 1. This is x is equals to minus root 7. And again, it will go to minus root 7. I mean, x is equals to root 7 here. Right.
Okay.
Now they say we have to evaluate f is strictly increasing in 10 to infinity. Correct, because 10 will be somewhere here. And after that, my graph is increasing because there is no other zero. So graph cannot come down to cut xx. It will always increase. So that's why this option is correct, I guess. Right?
Yeah, I didn't check that, so I just got half mark.
It is correct because after 10, I mean, if you want, if the graph want to decrease, then it should have another zero. But we don't have any other zero except these three things. That's why it's a correct option.
Okay, this is strictly increasing means
Now the
it's
second
going
one,
up. It is not having any other
it's going up.
Okay.
It does not have any other turning point and come down. So now G has two turning point and Y coordinate of only one turning point is possible. And Y coordinate of only one turning point is possible. Now G is what? So G is nothing but minus G of x is nothing but minus 2 of f of. Am I audible?
Yes, sir.
Yeah, you can view the recording of this session, I think. Okay. So now gx is nothing but some scaling of some stretching or compressing of this graph. So that means the graph of gxx will look a bit of similar of this, but because of minus thing, the gx will change. So g of x is what? Minus of f of x. That means we have to do minus 2x cube plus 16x square minus 40, right? So the roots of this polynomial is again the same. X is equals to 1, root 7 and minus root 7. 1, root 7 and minus root 7. These are the roots of g of x also. But because of this minus sign, the graph of g of x will look a bit different. Now, our g of x is an cubic polynomial with a negative leading term. That's why it will start with here, from here. Because of this negative leading term, x goes to minus infinity will imply p of x will also go, p of x will go to plus infinity. Right? That's why we have to start from here. And all the roots will have a negative all the roots will has a odd multiplicity. So that's why minus root 7 will be here, 1 will be here, and root 7 will be here. So the graph of polynomial will look like this. This is a graph of g of x now.
Okay. Can you just summarize this how we have to start the graph? Just now you said no, that minus means like on top, and that alone, if you can just summarize, it will be nice one. Because end behavior we can understand, but then how when we get the roots from where to start the graph, that is not very clear.
Okay. See, when we have this behavior that x goes to infinity implies p of x goes to infinity. So that means as you are moving toward the left hand side of our graph, the p of x is going to upward, right? Because the positive infinity is situated at the upward thing. So that's why we have to start from here, right? In this scenario, you have to start from upside.
Yeah,
As
it's
x goes to
positive.
infinity, imply p of x goes.
Okay.
And I'm sorry, x goes to minus infinity because we have left hand side. X goes to minus infinity, imply p of x goes to infinity, then we have to start from the upward side. And if x goes to minus infinity, implies p of x goes to sorry, P of X also goes to minus infinity, then you have to start from downward chain. Okay, so I write it. So if you have this condition that x goes to minus infinity implies P of X goes to infinity, then you will start from here. Okay. And when you have this condition, x goes to minus infinity, P of X is also going to minus infinity, then you will start from here, this, and here, this. Okay. You can easily observe by graph that how your px moves. Okay.
Okay. Okay. Thank you.
Okay, so I'll move to next person. What's going on in chat? Okay, so Vindhya, please unmute yourself.
Yeah, ma'am. Shall I post my question again in the chat?
Please.
Yeah, I've done it. I've posted it.
I haven't seen.
Can you see it, ma'am?
Yes, no, I'm not able to get it. Where is your? Oh, okay, I got it. Consider to polynomial this one, right?
Yeah, it was in the graded assignment.
Mm-hmm.
First of all, I was
So
unable
consider
to
a
find out the zeros of this.
Okay.
And also how to see if q of x is going to infinity, if x is going to infinity. I was unable to solve this problem.
Okay. So let's.
Because we can know the turning points of p of x only if we know the zeros of it, but I was unable to do it.
Mm-hmm. Right. So this is your question that consider to polynomial P of X. Which of the following is true? So we have to find out the end behavior and turning points and the quotient obtained by dividing Q of X by P of X constant. Okay. So here P of X is what? It's a minus of x to the power 5 plus 5x to the power 4 minus 7x minus 2. This is your P of X, right? Right, I have written the right expression. So here you get an intuition that x is equals to 1 may help us. Minus 1 plus 5 minus 7 minus 2. No, it won't. X is equals to 1 also won't help us. This is a graded assignment question or what? X to the power 5 plus 5x. Okay, we don't P of X. P of X has at most 4 turning point. So I think this option is correct because you just have to argue by degree because the degree of P of X is 5. So thus P of X can have at most because they've written at most, right? Not exactly. So that's why you can argue this at most kind of thing using the degree of polynomial. So since the degree of polynomial is 5, so that's why the P of X can have at most 4 turning points. So you can argue by degree fact that if we have n degree polynomial, then it will have n minus 1 turning points. Now it's clear? Because obviously you can't find the root of this polynomial very easily. By hit and trial also we have to think some other things. So is it clear now, India? Now you can unmute yourself.
Ma'am, but how to find if p of x is increasing, if x is going to infinity?
See, you can See, this is an odd degree polynomial with negative sign. So you can use that. Just
Okay.
give me 1 second.
Hello, ma'am. Your voice is breaking, ma'am.
Hello, am I audible now?
Yes, ma'am.
So, by end behavior, we just discuss, right? So you can use refer to this chart.
Okay.
This thing.
So we
I
need
have
not
done
always
all,
graph,
all
is
things.
it?
Yeah,
The
this
polynomial.
is even. No, ODG. Sorry, what? Yeah, I mean, in some cases we need the graph, but in these general things we don't need the graph, right? This is a general because it's a very big polynomial. You can't easily find out the roots.
Correct.
Obviously, you have to use the motivation of degree. Sorry.
In the graded assignment, there was one more question similar to this, the second question, where the leading coefficient was 1 by 1000 into x plus 1 square, that one. So for
Yeah,
that,
I also had a doubt in that map.
yeah, so in
Yes,
that
ma'am. I
question,
also
I
have a
tried to
doubt in that
graph it out.
question.
It didn't work out. Then I was stuck, so I'm not sure how it works.
That means you have to go by the degree concept and the leading coefficient concept. If your degree is odd, leading coefficient is positive, then you know how does the graph look, right? So is that clear now? I mean, you still want to discuss our end behavior of graph?
Well, if you can discuss that question, it would be very helpful.
So can you post it in the chat?
Yes,
I'll
ma'am,
discuss.
it's graded assignment, second question. I'll post it right now.
Ma'am, can you take my problem, please? That I've discussed earlier. Actually, I'm not able to attend to morning class. That's why I'm asking the question again and again.
Okay, please send in the chat box now because it may missed. What's your name? Udmi? So that I can.
Ma'am, my name is Sakshi.
Sakshi. Paste your question now. I'll discuss it.
Ma'am. Ma'am, actually, in the last question which you explained just now, if there is a question regarding multiplicity, then we need to factorize that entire thing.
Right. If in as a multiplicity, you can only find if you have factorization. Otherwise, you just say one, but for exact multiplicity, you need to find. So we have to find what will be the height of edge the wooden block. You have to say, and this is your wooden block. Okay. So what's the polynomial? Actually? What's quadratic? Oh, got it. Yeah, got it. Another. So okay. This is an SSC question here. Okay. So in this question, they say P of X is the thing. P of X is simply X minus 2, X minus 4, and plus Q type of thing. Okay. And she has been asked to curve it using the best fit of X. So we have to find out. Okay.
It's really similar to the question.
Similar to which question? They haven't given any other.
This is the SSC question, right? That we solved before. This is very similar
Yeah,
to
this
that
is a
only.
SSC question. But here we have to find out the value of h, right? The height. We can use the best fit. I mean, we can find out the value of k. We can find out the value of k for which it is a best fit. So have you find out the value of k? Sakshi, I would try to find out the value of k.
Yes, ma'am. The value for k is equals to 10.
K
The
is
height
equals
is
to
nothing
10,
but
right?
the highest value of y.
No. But it's a highest value of y.
Ma'am,
X
Y is
minus
going to be
Exactly, ma'am.
infinity,
two.
isn't
Look at the
Right.
box.
So
Y
this
equal to 18 is the maximum number, highest number. That is the value of
yeah.
height.
No, that's not the case, I think. Because
I checked out, ma'am. You can try out, ma'am.
has. So why they ask about h? I mean, highest. Obviously, 18 is the highest number. Highest.
Yes, ma'am. The height of the wooden box is 18.
Because at x is equals to 6, we have the highest value. But what's the point of finding k then? Because it's clear from the table itself, right?
There is two questions to find the k and height.
Okay. So in which question you have doubts actually for finding the value of h only, right?
Yes, ma'am.
Hello?
Yes, ma'am.
So the value of h is 18 here, right? Because of the table itself, we can see that she has been asked to curve it in such a way that the curve p of x can be best fitted according to the data given below in the table. So that means x is equals to 6, the maximum value is 18. So the height should be 18. Then only it makes sense, right? So the answer is
Okay, ma'am.
18 of this question.
So ma'am,
Height.
this will always be same for similar questions. So we don't have to find height in a specific way.
Right, because height is the maximum value a table will take, right? And here the maximum value is 18.
Okay, ma'am. Okay. Thank you, ma'am.
I think the height is depend on the graph given.
Graph K itself also.
Yeah.
Let's put x is equals to 6 in our obtained graph. If I do that, then 6 minus 2 will become 4 into 2 plus 10. Then, okay, so now it's 18. So that's why its height is 18. See. So what you have to do for finding the height, you have to find out what is the maximum, what's the maximum value of p of x with corresponding to maximum input here. X is equals to 6. That's why it's coming out to be 18. If there is if this is not 18, the value of k is now it's clear.
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Yes, ma'am.
Okay, fine. Let's move to another one. If this a is equals to y as consideration, and what is the minimum number of events that are must be? See, this question, Tushar have posted one question that there's one. See, there they say that RR must the number of elements that R must be, right. So for equivalence relation, we have to satisfy the three conditions, right? Reflexivity, symmetricity, and transitivity. So if I want to satisfy reflexivity, I have all the pairs of this type, A comma I belongs, right? Here there are four elements in A. So that means at least four elements should be there in R. Just one observation we make from reflexivity. Now, what about symmetricity? So see, if I take these four elements, then also my symmetric condition will satisfy, right? Because there is no such pair AB and BA type of thing. What does symmetry say? If AB is there, then this will imply B is there. But if I take all the elements of A comma type of thing, then symmetricity is already satisfied, right?
Yes.
Now let's come to
Yes, ma'am.
transitivity. For transitivity also, I need a pair AB and BC type of. But if we don't have BC type of pair, then also transitivity is trivially correct. So that means at the end, we just need four elements of the type A comma A for forming an equivalence relation. So the answer is 4 here. Now is it clear?
Yes, ma'am.
Because
Ma'am, can
if
we
you
take
take
4, 4,
identity,
4, 5, and 5, 4?
but here we have to find out minimum. But then reflexivity won't satisfy, na? For reflexivity, we have to take E comma type of thing. That's the restriction is there.
Ma'am, there was 4, 4 for reflexivity.
No, but
Reflexivity.
reflexivity, what does it say? It say A comma A belongs to R for all A belongs to A. All elements should
Okay,
relate it to themselves. Then only it will be reflex. If you take only one pair, then that won't satisfy reflexivity. Okay.
Okay, ma'am.
So now another question.
Ma'am, so
The
for
answer
this
is
question,
you have
the
any
We can
doubt?
answer
do
would
this
be
question
one
by
pair.
SSC.
Which
Ma'am,
question?
could you please explain multiplicity?
Ma'am, can we do
Multiplicity.
this? Ma'am, can we do this question by SSC?
Which question?
This height question.
Yeah, this is purely based on SSC because we have to find out the value of k. But for finding the value of x, what I'll do, I'll put the maximum input value in a required polynomial p of x because I will get the value of k to be 10. So if I put a p of 6 is equals to 18, so that's why the value of x is 8.
But why? How do we know that a 6 is the highest value? It could have been 8 also. They have not specified the domain.
Huh. So if it would, but she has to ask to curve that in such a way that the best fit according to the data, right? So if there is a 8 here, there's some value, then we have to check for it. That's the value of h.
Okay, okay.
Ma'am, I have sent one question, polynomial one.
Ma'am, in the last question you just explained, ma'am, the answer would be 1 in that case.
In which case, the
Ma'am,
other case
we need only
relation.
one pair of elements for it
No,
to be
no.
reflexive, symmetric, and
No, we don't need only one. We need four elements because reflexivity says that every element should relate it to itself. It means all A comma A should be there for all A belongs to it. And there are four elements in it. That's why we need four pairs.
okay, at least 4 pairs should be there. Okay, to
Yeah.
satisfy reflexivity so that others are also satisfied.
Right.
Fine.
Ma'am, I had a doubt in which it was telling to find the points of intersection, but the equations were in the form of cubic and quadratic equations. So I was unable to do that without using Desmos. Now I'm sending the question. Can you please check it?
Yes.
Just now I sent it for the.
Manas, this
Yes,
is
ma'am.
you. The Ministry of Road Transport. Okay, this question. So what you have to do, you have to find out the intersection point of those things, right? So what you will do, you will just take fx is equals to gx and find out the value of x. Then you can easily solve this question. See, in this question, what you will do, take f of x is equals to g of x. Right, so when you do that, you will easily find out x minus 13, x minus 11 square is equals to x minus of x minus 13, x minus 11, right? So if you do that, then this term will get cancelled out, and this also got cancelled out. So x is equals to 11, we can easily get. That's one intersection point you could find.
Ma'am, could you
That
once
means
again
x is
say why
equals
are
to
you
11.
equating both the why are you equating both f of x and g of x?
Because what they say
Answer
that
is
what
10,
will be
x
the
is equal
x
to 10.
coordinate of the third.
It's an intersection point. That's the reason we're doing that.
We have to find out the intersection point. I think.
The answer is 10, x is equal to 10.
X is equal to 10 is the answer.
Yes, yes.
What I did here.
It is very simple, ma'am, not complicated.
The third one.
This, sorry, what? The answer is correct. I'll just black out. The shape of two root R1 and following the polynomial respectively. What will be the x coordinate of the third expressionistic if the first two are x-intercept of f of x and f of x? So that
Ma'am,
means
get
this
the
is the only get the
ma'am,
all
not like
intersection
left,
point. Right?
all right to left, and just solve that. That's it.
The
Got it.
intersection for a
And what you have to
polynomial
do, you
or a
have to find the
no, for a polynomial, if you want to
right,
find the
right,
intersection, you need to minus.
right,
As simple as it is.
Ma'am, there x equal.
See, what will happen is you get this thing with the right. So plus x minus 13 and x minus 11 is equals to 0. So now
There
what you will do,
minus.
x minus 13 and x minus 11, just this is minus now.
The common,
Minus
you
will
can
become
take
plus
both the
0.
common, yes.
Take the both common, and this will be x minus 11 plus 1 is equal to 0. So that means x minus 13, x minus 11, x minus 10 are, that means the x coordinate of intersection points are 13, 11 and 10, right? But it so happened that 13 and 11 are R1 and R2. The two cities. Whatever they say, I mean, there are three districts. So 13 and 11 are those districts. And the 10 is the required next one.
Yes, ma'am. Understood, ma'am. Thank you.
Ma'am, just missed out on the last one, ma'am. What did you say in the last statement, ma'am?
The last statement here, they ask that what will be the x coordinate of the third aspirational district if the first two are at the x-intercept of f of x and g. So you can easily check the x-intercept of f of x as well. F of x is equal to x minus 13, x minus 11. So x-intercepts means those points where f of x crosses the x-axis. So you can take one of them as the first aspirational district, and similar with the g of x also, that the second one will be the second aspirational district, and 10 is the only x is equal to 10 is the only point which is not an x-intercept of either of them, not not neither of f nor of g, right? So that's why the 10 is the answer. Is it clear now?
Ma'am,
Yeah,
I
ma'am.
have sent one photo. Can you please explain the first option of that?
Yeah. This one, right?
Yes.
Ma'am, if mod comes, actually, I don't know how to solve this.
Yeah, mod is the only thing that creates confusion.
I don't know how
Okay.
to solve that mod.
Take both minus and plus sign when you do it. It's easy.
Huh. Yeah, mod of
Take
x
both the values.
minus x is, does it say for street? Acha, ठीक. See, uh, uh, one thing I wanted that the graph mod of x is this thing, right? This is the graph mod of x. The
Are you showing
minimum value
something?
is the, yeah, as my screen is visible, right?
Screen is not visible,
Or
ma'am.
whatever you are writing, we can't see that.
Okay. There's some information. Now is it visible?
I had started.
No, ma'am, not till now.
Ma'am, your
No,
screen
not
is not
visible
visible.
now.
And
Now,
now it is visible.
Yes, now it's
It is
visible.
visible.
see, in this case, what I have to do, the mod will take a minimum value
Are you writing something?
at 0. Hello, am I audible?
Are you writing something?
You are.
You are audible. The slide is audible, but like we can't see whatever you are
You
writing.
can't see I'm writing
Now
something.
you
Okay.
now you are moving the
Just
cursor that we can see. But if you are writing anything, we can't see.
actually video itself. Okay, fine. See, what happened? Mod will take a minimum value where it will become 0. That means mod x will take minimum value at 0. Yeah, I'm not writing. I'm just verbally explaining because I don't know what's happening here. I'm trying to write, but it's not well done. It's visible. I'm writing mod x.
No. Even your voice is cracking little.
Okay.
Bit.
Ma'am, I think you're
Yeah.
sharing window.
Windows. Yeah.
Maybe unshare and share again the screen.
Okay, it will see. What do you want to ask? ABC, you want to ask A, right? Hello.
Yeah. What
Hello.
were you saying?
Voice is correct.
What can I do with?
Can you say it again? It was cracking.
Now clearly. Hello.
No. Yeah. Now you can speak.
See, I want to ask that which option you want to ask, A, B, or C, D. Which one? A1.
Yeah, A.
The mod will minimum value when the inner function will become 0. So if you have mod x, then the minimum value is at x is equals to 0. If you have mod x plus 12, then the minimum value is at x is equals to minus 12, right? So that's the point you use here. One point, the minimum value of f of x will become 10, and x become when x, which is again 10. So that means the minimum value of f of x is 10, minimum value of g of x is 10. So that's why the multiplication of minimum value,
Yeah, I
maximum
got
value
it.
they
So
say of g
whatever
of x,
will
right?
be under mod will take its exact opposite, right? If in the case of x it will be 0, but in the case of like
Case
with
of
some
x plus.
these values like plus 12 or plus 11 or whatever it is, will take its exact opposite, right? Yeah, thank you. Can
Right.
you just briefly explain the option B?
Yeah. So the option B says there are infinitely many polynomials p of x of degree 4 such that p of 4 is equal to 0. P of 5 is equals to 0, P of 6 is equals to 0. So that's right, because you simply take polynomial whose roots are 4, 5, 6, and take
Your voice is
multiplicity of
cracking.
that polynomial P1.
Ma'am, you're not audible. Your
I'm
voice is.
sorry.
Your voice is cracking so much, we can't hear you.
Hello, am I audible?
Yeah,
Now it's better, ma'am.
Actually, there is Wi-Fi issues happening.
Okay.
See, you take any polynomial whose roots are 4, 5, and 6, right? And made the polynomial in such a way that it will be 4. But multiply that polynomial using any constant. You can multiply that constant by 5, then also it's a polynomial, right? Multiply the constant by 6, that's also a new polynomial. That's why there are infinitely many polynomials of degree 4. In such a way, 4, 5, 6 will be the roots, but all the polynomials are distinct, right? Just multiply a constant. If you get one polynomial, you multiply by a constant that number, you will get several many polynomials. The same property, the same root, degree, right? Am I audible?
Yeah,
So this
your voice is not clear. Neither it was.
So you are saying that any polynomial multiplied by a constant, so we will get thousands of results, but the same roots, something like this, correct?
right. You can use this.
Yeah, I got it. Thank you so much, ma'am.
And the last one
Ma'am, I have sent a question in the chat.
Ma'am, I have sent
Please
a
look.
question in the chat box.
I do.
We can't discuss so much question. These questions belong to which thing? I mean, you should ask in the regular sessions these doubts. I mean, if there are questions from practice, these are premium questions.
Most of the
Yeah, I've
questions are
already
from
done
graded
all the
assignment.
fix.
Take rest.
Yeah.
We will discuss in the later sessions, like the next sessions. It's okay. Thank you so much for the session.
Thank you, ma'am.
Thank you, Los. Thanks a lot.
Okay, thank you guys for joining.
Thank you, ma'am.
But I think
Thanks, ma'am.
Thank you, ma'am.
Bye bye.
but
Good
you
night,
don't
ma'am.
want the PDF. I'll share. Wait. Don't leave.
Yes, ma'am.
We want
Share
PDF.
my
If you
PYQs
can share.
also. I'll share my PDF and one PDF of PYQs also, which I have with me.
So you will share in the chat now.
I'll share in the chat. Just wait a minute. I have 2 files to share. Okay. This one is of PYQ. And this one is from Cherry. Okay, both will help you. Just wait a minute. There's a bit internet issue.
Ma'am, in qualifier exam, we
PDF with
have
everyone.
Okay, ma'am.
Sorry,
We
what?
have only medium. I mean, in qualifier exam, we have only medium level of hardness to solve the questions.
I can't hear you. Sorry. What you saying?
I asked for, ma'am, in the qualifiers.
Hello, Bala.
Yes, ma'am. Am I audible?
Yes.
Yeah.
I'm asking that in qualifier exam, particularly in mathematics, we got in the solve the problems in the medium level or easy level.
See, there are some problems which will be easy. There are some problems which will be medium, but there will be definitely 1 or 2 problems which are tough. So if you want to get a very good score, you have to go through questions, right? Because we don't want everyone to get good score. You can get medium score, but for good score, you have to
I
do
mean, go
some
through the
hard work.
last 5 qualified question papers. like I'm just solve every questions. Is this okay to attend the qualifier and get a pass mark?
Sorry, what? You're not
Again,
audible. It's clear.
yes,
Can you
ma'am.
repeat? Ha.
I'm asking that I saw I go through the last 5 qualifier question papers
Ha.
and I solved
Is it
Yeah.
every
okay,
single
bro? Okay,
questions.
okay.
What okay? I'm asking a question. You said, is it enough to get a pass mark?
Ha. Yeah, it
Ma'am,
is
the
enough to get a
PDF,
pass mark.
ma'am,
That's
PDF
what
we
she
were
said.
not able to receive.
Yeah, sorry, PDF is not getting uploaded. So I'll share you in some other way. And either I'll share you in the next session if they happen, or in somewhere else. Okay. Or I'll post in
Thank you.
Discourse or Gmail where I can. Thank you for joining.
Okay, ma'am. Thank you. Thanks a lot. Bye-bye.
Thank you, ma'am.
Hi, ma'am. Thank you.
Bye. Good night.
Thank you, ma'am.